students, welcome back to our next video of separation techniques. So today we'll be seeing the separation of liquid gas mixture, and only one method is there in liquid gas mixture. The method is boiling. So by boiling, what we'll be able to do, we'll be able to separate the given gas from its liquid component. It's a very simple and easy method to remember, and the liquid component over here we are taking it as water. Gas we are taking as CO2. So this is the example which you can remember for the separation of a liquid gas mixture. And here the principle behind the separation is that there is decrease in the solubility of gas. So what is happening? Why there is decrease in the solubility of gas? Because we are increasing the temperature. So as the temperature increases, what will happen? The solubility of gas in a given solvent is going to decrease. That is why the CO2 gas on boiling will escape out and the water component will be left behind. So here the separation is based on the concept based on the fact that there is decrease in solubility. When will this decrease in solubility happen? When there is increase in rise of temperature. And you will remember the example of carbon dioxide gas mixture which is dissolved in water, and CO2 gas will escape out on boiling. Next, coming to gas-gas mixture, we have got two methods. First method is diffusion, and the second method is solubility in solvent. Let's understand what do these two methods help in. Firstly, when we are talking about diffusion, it is based on the concept that how denser or lighter a gas is. So we are taking the example of two gases, that is hydrogen and oxygen gas. Now we all know that hydrogen gas is lighter as compared to oxygen gas. Oxygen gas is more heavier as compared to hydrogen gas. So in diffusion, what we are doing, we will separate both the gases by passing it through a porous partition. Okay, so for example, if these two gases are placed in a container, we are going to separate these two gases by passing them through a passage or through a porous partition. So what will happen? Hydrogen gas being lighter, it will diffuse more rapidly. It diffuses more rapidly as compared to oxygen gas, because oxygen gas is heavier, so it will diffuse less rapidly, and that is how we'll be able to separate hydrogen and oxygen gas. Next, coming to solubility in solvent, it means if we have taken a mixture of two gases, out of these two gases, one gas will be highly soluble in a solvent, and here solvent we are considering as water. Okay, so very important, because later on in your higher grades you'll get to know that when we talk about HCl gas is highly soluble in water as compared to nitrogen. Nitrogen is almost insoluble in water. So this is important for you to remember, because at times these questions can be asked in your MCQs also, that they may ask you that which gas is highly soluble in water, giving you four options in which you have HCl, nitrogen, and other two options might be given. So you have to remember that HCl gas is highly soluble in water. So the solubility of gas in water, what will happen? When we are going to dissolve these two mixture of gases, HCl gas will dissolve in water, and later on we can obtain the dissolved gas in water by boiling. So by boiling, what will happen? The dissolved gas in water is expelled by boiling. So HCl will dissolve in water, whereas nitrogen will remain insoluble. So these are the two methods which you are going to remember for gas-gas mixture. We have the example of hydrogen and oxygen, and we have the example of HCl and nitrogen. In diffusion, you need to remember it depends on the fact that how lighter or heavier a gas is. Hydrogen being lighter, it will diffuse more faster or rapidly from a porous partition, whereas oxygen will diffuse less rapidly. And when we are seeing the example of HCl and nitrogen, HCl will dissolve in water because it is highly soluble in water, whereas nitrogen remains insoluble in water, and that is how we'll be able to separate the given two gas-gas mixtures. Moving next to the last part of this chapter, that is complex mixture. Now in this we have got two methods to see. First method is chromatography, and it is based on the difference in adsorption of solid constituents. Okay, this method is called as chromatography. So what is chromatography? In this we are going to see that we are separating the mixture of different solid constituents in a liquid constituent. So here you can see we have taken solvent as water, and we have taken an ink drop, and this ink drop we have placed on the filter paper. Okay, this ink drop has been placed on filter paper. Now ink is a dye, and this dye is made up of different solid constituents. So how we'll be able to separate the different solid constituents of an ink? First, we have taken an arrangement. We have placed a solvent, that water, in a beaker, and we have hung this filter paper. On this filter paper we have placed an ink drop, and this arrangement we are going to leave it for few days. So what will happen? The solvent will flow over the ink drop, or the ink spot which we have placed. The solvent will flow over it, and what will happen? The solid constituents of which this ink drop is made up of, it will be separated out, and you are going to see different colors on the filter paper after a few days. So what has happened? This process has taken place by a surface phenomena which we call it as adsorption. What is adsorption? Adsorption means that the ink drop which we have placed on the filter paper, it is present on the surface layer only, surface layer of the filter paper. So, and the solvent, which is water, is moving over this ink spot, and what is happening? When the water is, or the solvent is flowing over the ink spot, the solid constituents of ink are getting separated out, and we are going to see different colors on the filter paper. So by this method, what has happened? We are able to separate the solid constituents which are making this ink. The ink is made up of different dyes which has got different solid constituents, and these solid constituents are removed when water, that is the solvent, passes over it. So that is how we are able to separate the ink from its solid constituents, by the passage of solvent, that is water. So that is chromatography, which is based on difference in adsorption of solid constituent, that is dyes, on the surface of an adsorbent medium. What is the adsorbent medium over here? Adsorbent medium is the filter paper. Next is centrifugation. So in complex mixture, first we have chromatography, second method is centrifugation, and in centrifugation we separate two different constituents which have different densities. Okay, so here the principle behind separation is the difference in the densities of the two components which are present. So it is based on the principle of different densities. So what we have taken, and what is centrifugation? It helps in the separation of mixture using a centrifugal force. So what is a centrifugal force? It is a force exerted by a revolving object. So this whole apparatus will be revolving. So as it will be revolving, what will happen? The more dense component will move away from the axis of rotation, and it will settle down at the base of the test tube. So if we talk about the example of separation of cream from milk. Now from this simple example, you know that cream is much more denser as compared to the milk. Milk is less dense. So what is happening? When we subject this separation technique, we place this in an apparatus where the test tubes will be rotating, and once this rotation will happen, what will happen? The centrifugal force will cause the denser particles to settle down, and the less dense particles will move towards the axis of rotation. So what will happen? Once the rotation is complete, the cream is going to settle down, okay, and milk will be collected on top of the test tube. So what has happened? A revolving object, that is, this apparatus is exerting a force, because of which what is happening? The denser particles are settling down. They are migrating away from the axis of rotation or the axis of centrifugation, and they are settling down at the base of the test tube. Some more examples which we can see for centrifugation is that in labs when the blood sample is taken, the blood can be separated into its different components. Now blood, we all know, is made up of plasma, WBCs and RBCs. So all these components can be separated by the method of centrifugation. Then in washing machines, you must have seen how the drying of clothes takes place. By the centrifugal force, what is happening? The spinner moves and the water is moving outwards, and that is how the clothes get dried in your washing machines. And obviously in labs, when we are separating the precipitate from a given solution, we do this process of centrifugation, because of which the solid particles, they settle down, and then we are able to separate the precipitate from its from that given solution. Okay, so in complex mixture, you will remember these two methods. In chromatography, you will remember the example of separation of ink. That is, ink which is made up of dyes has solid constituents, and these solid constituents are removed by the adsorption of solvent. When the solvent is moving over that ink spot, that solvent is helping in the removal of its solid constituents, and we get different colors exhibited on the filter paper. And in centrifugation, based on difference in densities, what is happening? The more denser particles are settling down, and the less dense particle is moving upwards by the effect of the centrifugal force. This centrifugal force is used for the separation of complex mixtures. Now to summarize all the separation techniques which we have seen and all the types of mixtures. Now children, if you go through this mind map or the summary map which is there in front of you, it will help you to remember all the examples and all the types of mixtures. Now we have already seen the solid-solid mixtures. The first method we saw was of sublimation. Example was of ammonium chloride from sodium chloride. In magnetic separation, we saw the example of iron and sulfur. In solvent extraction, sulfur and charcoal. Solvent means sulfur will be soluble in carbon disulfide solvent, and that is how we will be able to remove sulfur from charcoal. And in fractional crystallization, we saw the example of potassium nitrate and potassium chlorate. That is again a very important example which you need to remember. Next was solid liquid mixtures. We saw the simple methods: filtration, sedimentation, evaporation and distillation. So filtration, we saw calcium carbonate separated from water. In sedimentation, we saw sand and water being separated. In evaporation, we saw salt and water being separated, and in distillation also we saw salt and water being separated. Then liquid mixtures, very important, because many important questions and diagrammatic based questions can be framed based on the separation technique. We saw the example of oil and water, and the principle behind the separation technique was difference in densities and immiscible liquids. Oil and water are immiscible liquids. And in fractional distillation, we saw methyl alcohol and water, and methyl alcohol and water are miscible liquids, and they have difference in their boiling points. Difference in boiling points, which was helping in the separation of these two mixtures. Okay. And then next we saw boiling just now. In boiling, we saw the example of CO2 and water, how CO2 and water can be removed by just boiling. Then in diffusion we saw the example of hydrogen and oxygen. Based on the densities of the two gases, we are able to separate both the gases. Then solubility in solvent, we saw the example of HCl and nitrogen. HCl is soluble in water and nitrogen is insoluble in water. In chromatography, we saw the separation of ink from its constituents, and in centrifugation we saw the separation of cream from milk. So all these examples and types of mixtures, please make a note of it. You can write it down, and this will help you during your examination times to just summarize all the types of mixtures along with their methods and their example. So this summary is very important for you to have a quick recap of the whole chapter. Okay, now we'll quickly discuss few simple questions based on separation techniques which we had discussed earlier. So let me see if you can give answers. The questions are on your screen. If you can just go through all the questions, we'll start discussing the questions. Coming to the first question, it is asking which method is used to separate sand and water. Very simple. Sand and water, they will not dissolve into each other. Sand particles are going to settle down, and hence by sedimentation we can separate, or you can also say by filtration. Both the answers will be correct. By sedimentation or by filtration you can separate these two mixtures. Okay. Which method separates immiscible liquids? What are immiscible liquids? The liquids which do not dissolve to form a uniform or a homogeneous solution. So immiscible liquids are oil and water, and the method will be separating funnel. I hope you are finding the answers for the other questions also. Please keep trying. Don't wait for the answers. That will help you to get a quick analysis of how much you have understood from this chapter. How will you separate iron filings from sand? Obviously, iron can be separated by a magnet. All the iron filings will stick to a magnet. So, by magnetic separation, we can separate magnetic separation. Okay. So, we can separate the iron filings from sand. Again, oil and water can be separated using which method? Separating funnel. So, see how the same thing can be asked in different forms. Here it is asking in the form of immiscible liquids. Here it is directly giving you the example. So, you should be very clear as to what is the difference between immiscible, miscible. All these are important and key words in this chapter. Now, sulfur from a mixture of sulfur and copper, we know sulfur dissolves in carbon disulfide solvent. So, the method used over here will be solvent extraction. Next, benzene. Now, here you can see difference in boiling points are given. Benzene has a boiling point of 80 degrees Celsius. Toluene has a boiling point of 110 degrees Celsius. And because there is difference in boiling points, we can say that the method involved over here will be fractional distillation. Fractional distillation, because they will be forming miscible liquids. They will dissolve into each other. Difference in their boiling points will help in the separation of benzene and toluene. Benzene will evaporate first, leaving behind toluene in the distillation flask. Now, potassium nitrate from a mixture of nitrate and chlorate, potassium chlorate, it will be fractional crystallization. Based on the difference in their crystallization, they are going to be separated out, potassium nitrate and potassium chlorate. Now, mixture of ammonium chloride, this is an easy one. We all know ammonium chloride undergoes sublimation. So, by the method of sublimation, we will be able to separate ammonium chloride from potassium chloride. Now, lead carbonate is insoluble. Now, because it is insoluble, we can use the method of filtration to separate lead carbonate from water. And lead nitrate, which is soluble from water, either we use distillation or you can use evaporation also for separation of lead nitrate from water. But if we want both the components to be collected separately, then the proper method will be distillation, because in distillation flask, lead nitrate will be left behind and water will be collected in the receiver. So these were few of the questions. Please go through this chapter and please learn the summary of this summary chart which I have discussed earlier. That is this particular summary which talks about the separation of mixtures. This will help you to learn all the important mixtures and their separation techniques. So thank you children, and we'll meet in the next video with a new chapter. Thank you.